Did you put it in my
Is the quiz going to be on just the new stuff or the whole unit?
I'll tell you in a minute. All right, so we covered pedigrees back in 7th grade. Just hold off on that other stuff for a minute. We covered pedigrees in 7th grade. We did them fairly simply, but really they don't get too much more complicated. So if you remember, a pedigree is a way of showing in a family how different traits are inherited through the family. You can think of a pedigree as like a family tree, but it shows who has certain traits. It can also show who's a carrier of certain traits. By looking at the pattern of how different traits are inherited, we can understand if the trait is sex-linked, if it's dominant or recessive, by analyzing sort of the pattern of how it's inherited through the family. So we use squares as the symbol for males. We use circles as symbols for females. Okay. Two individuals get connected side to side to indicate that they had children together. Children go below the parents. Parents go above the children. And we did all that in 7th grade. But there's some additional information that you can indicate on a pedigree. Okay. Sometimes it's used to show, sometimes they can show twins. So the methods of showing twins, these are dizygotic twins, these are monozygotic twins. What the heck does that mean? Dizygotic, two zygotes, meaning fraternal twins. Okay? If they're from two separate eggs, they're fraternal twins. Monozygotic means both twins came from a single zygote. Those are identical twins. So they're connected sort of in this way. So these are identical twins, these are fraternal twins. We also can indicate whether or not a trait is, a person is a carrier for a certain trait. So we know that in certain circumstances, a person can be a carrier for a disease or an illness without actually having the illness. Okay? If the disorder, if the disease is dominant, or if it's recessive, and an individual is heterozygous for that trait, well, they won't show the symptoms of the disorder, but they still are a carrier, and they still have the ability to pass that on to their offspring. So when we're showing a carrier, we shade in half of their symbol. Okay? So shading in half means they're a carrier for a certain trait. So these individuals are all carriers. All right, so as we look at a pattern of inheritance, as we see how certain traits are passed on through the family, well, we can analyze that, look at the parents, look at the offspring, and we can tell if this trait is dominant or recessive. We can also often tell if it's sex-linked or not sex-linked.
Why does it say shoes?
Where?
This is shoes. Right after recessive.
Shoes,
it says
because shoes. Shows, shoes. It's an alternative spelling of the word shoes. So
Correct.
when we look at a pedigree, we can tell if the trait that it's showing is dominant. Okay? If you have a parent with the trait and one without the trait, and when you look at their offspring, if their offspring, we would expect half of their offspring would have it. If it's dominant, we would expect that at least 50% of the offspring would have that trait if it's dominant. Okay. It depends on the genotype of each parent. Okay. We can tell that a trait is recessive if it shows sometimes even when neither parent has it, okay? So if both parents are heterozygous for a trait, okay, and they have offspring, we would expect 25% of the time to show the recessive trait, that would be an indication it's recessive. When we look at the pattern of inheritance, if we find it's more often shows through in males, it may be sex-linked. Okay? It could be just due to chance, but if we see a pattern of inheritance that shows much more often in males, it's often sex-linked. Remember, the sex-linked trait, it's easier for a male to get a recessive sex-linked trait because they only need to get one gene for it, because they only have one on the X chromosome. We would know that it's probably not sex-linked if males, because remember, males only pass on a Y chromosome to their sons. And so if it's a non-sex-linked trait, we may find that males are passing on to their sons, and it's probably equally common both in men and women. All right, any questions about pedigrees? We'll get some practice today.